Welcome to Vitamins with Muhammad Said. Today we are continuing with scientific computing using Python programming. Very interesting. Today we want to introduce one of the NumPy function that is very important, enable you to ease the process in scientific computing. These functions, we have NumPy learn space function. This one will help us to define the range of intervals beginning and to end, and there you can define the number of ordinates you would like to see. And also another function inside NumPy we want to talk about, because they are many, but we are beginning with this one. Another one is called NumPy power function. This one shall be able to talk about the base and exponents. Here for you now, we are starting by importing our NumPy library. Now we begin import NumPy as np. You run, takes you to the next step. Now we are beginning on our series, which are going to be listed in a learn space function inside NumPy. How do we do that? Very simple. The syntax is, you can define, we are defining by defining a variable, we are assigning, we equate it to NumPy dot learn space. This one is going to help us to define the length. It can be from negative floats, negative integers, to a positive integer or negative floats, whatever. Let's begin with the simplest one. Let me define from the negative one. We are doing it like that, comma, and that is where I'm starting from, to positive 10, comma, and then inside there, that range, I would like to take maybe around 10 items, or it can be 10, whatever, or you can reduce them to 5. The good things, this one, it even help you to arrange them with distancing them, not squeezing them, for easy usability. Let me just say maybe 8 items. Then from there you run. When you run, it takes you to a next cell. I'm going here to also to define another, define another variable. Then I equate it to NumPy power. As I said, also we are going to use it, NumPy power function, of which this one is going to help us to know the base and exponent. This one normally works when you have in question of which example we saw the other time in our series 1 up to series 2, where you have the question of y is equal to x squared plus. Okay, can take that example. The value here of the base normally has to be the you can define them, but let me define them as I take in this is my x, there as it is, then I say comma, the exponents, we shall see exponents, the power raising can be from the single dimension, 2 dimension, 3 dimension, multi-dimension, or you can use a scalar value. It can be scalar value for 1, let me say 2, implying that this is our x from here. Okay, then exponent is 2. If I run, it will take me to next step. Now, if my question was is equal to t, of which t has the base x, exponent 2, as we used to do that operators 2 times means power. This is the thing, it looks the same. The other one we are using it manually if you observe our series from the previous one. So this one we are using the power, which is exponent. Then if we run, it will take me to next cell. Very interesting. If I want to get an output for that in question, what do you do? Simple print parenthesis, then you call y. When I call y, it will give me, I run, it will give me the output. That is it. Very interesting. Person using NumPy library. NumPy has many functions. This is one amongst them we are talking about. Easy for you. How can you do scientific computing? Very interesting. Here for you. So, if you've known this, you can prefer to apply as many as you want, as we shall see in the future to come from now. Stay tuned with Vitamin. Very interesting.